Welcome guys. Today I'll be doing the inverse of a 2 by 2 matrix. Don't forget to watch all my videos on my YouTube channel, Mathematics MX Simplex, and please enjoy this video. If you do, please give it a like and share, and also subscribe if you haven't subscribed to my channel as yet. As I've stated, today I'll be doing inverse of a matrix. Let us start by talking about the matrix A, B, C, D. We want to know, how do we find the inverse of the matrix? To find the inverse, we have to talk about finding the determinant of a 2 by 2 matrix. And we use it using the original matrix A. So it is AD minus BC, and that gives us the determinant. Now the inverse of a matrix is 1 over the determinant of A times the adjoint, where the adjoint is where we switch the diagonals, so it becomes dA, and we change the sign, so it becomes negative B, negative C. Let us look at an example where we're going to find the inverse of the matrix A, which is 2, 1, 3, and negative 4. Now first, we have to go ahead and find out what is the determinant of this matrix A. So we know the determinant of a 2 by 2 matrix. We were given the formula. So the determinant of a 2 by 2, it is AD minus BC. So finding the determinant of this matrix A, we're going to multiply the first leading diagonal, which is 2, and negative 4 together, minus the next diagonal, which is 1 times 3. So 2 times negative 4, that's negative 8. And 1 times 3 is 3. So we have minus 8 minus 3, that's negative 11. Now we have the determinant. We can go about finding out what is the inverse of this matrix. So remember, the inverse of the matrix is 1 over the determinant times the adjoint matrix. So let us start by finding out what is the inverse. So the inverse of this 2 by 2 matrix is equal to 1 over the determinant, which is negative 11, and the adjoint, where we switch the 2 and the negative 4, so it can become negative 4 and 2, and we change the sign, so it's negative 1 and negative 3 for the next diagonal. Let us look at another example. We're going to find the value of P if the matrix A has a determinant of 4. So we're going to find the determinant of the 2 by 2. Remember, the determinant of a 2 by 2 is AD minus BC. So finding the determinant, we have to use this formula that we had learned previously. So we need to go ahead and do some multiplication in this matrix E. So we multiply 4 times 6. That's why you have the first bracket having the 4 times 6. Then the minus is coming from the formula. The formula has a minus in between. Now we're going to multiply the next diagonal, which is P times 2. So here you're seeing it with the arrow, the P times 2. And that is what you're seeing in the second bracket. Then you have it equal 4 because the determinant is 4. So 4 times 6, that is 24. Then 2 times P, that's 2P equal 4. Now solving, we carry the 24 over the equal sign, so it becomes negative 24. And we add it, so we have negative 20. Then divide both sides by negative 2. So P is equal to 10. Now a singular matrix has no inverse since the determinant of the matrix is 0. So it means that once we have determinant to be 0, we consider this to be singular because it has no inverse. Now, just a reminder, the determinant is still AD minus BC, and in this case, it should be always equal to 0 once it is a singular matrix. This example shows that it's a singular matrix. It means that we need to show that we will be getting 0 to be the determinant. So we need to go ahead and find the determinant of this 2 by 2 matrix. So we have 1 times 8, as seen in the first bracket, minus 2 times 4, that's in the next bracket. So calculating this, what we'll have is 1 times 8, that gives us 8, and 2 times 4 gives us 8. So 8 minus 8, that's 0. So the determinant is 0. And once we have the determinant to be 0, then it is a singular matrix. So here we have an example where we need to find out what's the value of D, given that this matrix is singular, so it's that the determinant of this matrix is 0. And if the determinant is 0, we can go ahead and find out what is it. So just a reminder, determinant is still AD minus BC. That's what we're going to use. So we're going to find the determinant of this matrix A and equate it to be equal to 0. So what we have here is 1 times 3 minus negative 4 times D, and it's equal to 0 because it's a singular matrix. 1 times 3, that's 3, and negative 4 times D, that's negative 4D, but because of the minus that's in front of the bracket, that is why you're seeing a plus. So carrying the positive 3 over, it becomes negative 3. Then we have to divide both sides by 4. So that means D is negative 3 over 4. So that means when I substitute D to be negative 3 over 4, I will find the determinant and it will give me 0, which signifies a singular matrix. Thanks guys for watching this, and if you like what you have seen, please like, subscribe if you're not a subscriber, and always stay tuned for new videos weekly.